Hello everyone, today we're going to be looking at hybridization of atoms. So firstly we need to learn about two different states of atoms. There's a ground state and an excited state. Over here I'm taking the example of carbon. So what will happen in the ground state of carbon? We know the ground state of carbon's 1s2 is just a normal electronic configuration 2p2. This is known as a ground state of carbon. However, in the excited state, what occurs is one electron from the previous orbital jumps into the next orbital. So it will become 1s2, 2p1, 2s1, sorry, 2s1, 2p3. Since one electron is being jumped from over here, so there's one electron in the 2s orbital and there's three 2p orbitals. So, why is this important? So, when bonds overlap in covalent bonds, which form between two nonmetals, as we know, hydrogen to hydrogen, when a covalent bond is formed, the atomic orbitals overlap to form a combined orbital, which will contain two electrons, which is known as the molecular orbital. As you know, in hydrogen, there's only a 1s orbital, so circle plus a circle. What will this make? This will make this type of shape. Sorry, this will make this type of shape with the two nucleuses over here, and this will form the s or the molecular orbital, the hybridized one. So, let us look at sigma and pi bonds. Sigma bonds will occur when the orbitals overlap linearly. So they actually overlap over here, right? This is a sigma bond. However, pi bonds are formed between the unused orbitals. So over here in carbon, as we know, only one atom over here is being used for the pi bond, correct? And there's one sigma bond here, one sigma bond here, and one sigma bond here, correct? And there's one. So if we draw the excited state of carbon here, here, this is 2s, this is 2s, this is 2p, 2p, 2p. We know three sigma bonds are being formed, so three orbitals are being overlapped, right? So let's just take these three orbitals as being overlapped. This means one pi bond is one unused pi bond is left, right? One unused p orbital is left. That means one pi bond will form. So this will mean there'll be a sideways overlap of the pi orbital over here. So this is the pi bond and this is the sigma bond. So let us take the example of ethine to learn this better. Ethine is simply hydrogen, carbon with a triple bond, carbon and then a hydrogen. Correct, isn't it? So basically what will happen is if we draw it out, there's one alpha bond here, sorry, sigma bond over here, because there will only be one sigma bond per overlap, per bond, and there's one sigma bond over here, and there's two pi bonds over here, right? Since two are not being used and only two sigma bonds are present, if we draw the configuration of carbon as this, we can see there's two pi bonds. So these two 2p orbitals are not being used, and these two are being used, correct? So these two orbitals will combine together and this will form sp orbital, and there'll be two sp orbitals, and this is the sp orbital here and this is the sp orbital here, and there's two pi orbitals which are the two p orbitals. So we can say the hybridization of ethine in carbon is sp hybridization. Let us take another example of hydrogen cyanide. Hydrogen cyanide is simply H, carbon and a triple nitrogen bond. So what can we see here? One sigma bond here, one sigma bond here, and two pi bonds over here for the carbon. So what do we know? Two pi bonds, and two sigma bonds. And these two sigma bonds, there is always sp hybridization of carbon. Now the interesting question is, what will be the hybridization of nitrogen? Right? The hybridization of nitrogen, as you know, there's two pi bonds over here, and there's one alpha bond over here, and there's a lone pair over here. You can add these two together. So we have two 2p orbitals which are not being used for bonding, and then 2 which are. So this will also be a sp hybridization. Now let us look at the example of nitrogen. So let's look at the diagram of nitrogen. What will it be? It will be nitrogen, triple bond, nitrogen. And as we just saw, 1 sigma bond, 2 pi bonds. So what will happen? This is a sigma bond and there's 2 pi bonds, the 2 p orbitals being there. So those will not be used. So those are unhybridized and not being used. So there's one only. So that means there'll be a sp hybridization for nitrogen also. Now, let us just learn hybridization because this is not very well taught in the AS course. Hybridization is just a mixing of atomic orbitals, right? Mixing one s orbital with 3 p orbital is called sp3 hybridization. So one orbital of sp3, which will be 4 present since there's 4 orbitals being used, will have 1/4 of the s characteristics and 3/4 of the p characteristics. Similarly, one s orbital and 2 p orbitals, there will be 3 sp2 with 1/3, 2/3, and one s orbital, 1 p orbital with like sp, which will have half s orbital, half p orbital. So, and why does hybridization occur? Hybridization occurs because all the energy levels, because S and P we know will have different energy levels, and when bonding occurs in an atom, all the bonds must have the same amount of energy level. So you can't form one bond with the S and 3 with the P. That is not possible. It needs to have equal energy levels. So over here these will have equal energy levels. That's why it will work. So let us take a look at this. So this is the p orbital. This is a modified p, so like sp, sp3, sp2, and with the s atom from hydrogen, this will be the molecular orbital because there's an alpha bond. So these two overlap, and this is the shape of the overlapped bond, molecular bond. This is another one. This is another modified p orbital, s, sp2, sp2, sp3, and this is the same. And these will form together to make this type of bond. We don't have to remember them. You can pretty much make them out of context. And finally, let's look at the hybridization. We have the S and the PX, PY, PZ as we know. They combine together. There's the sp3 and this is here. So this is CH4, this is CH3, and this is CH2. Sorry, this is C2H2 and this is C2H2. This one's wrong. It should be hydrogen over here and hydrogen over here. And this is sp or hybridized, as only these two are combining with the amount of pi orbitals. So you can basically find the number of bonds as the number of sigma bonds. So that will be everything. Wish you guys the best of luck and best of luck for your exams.